Any engine design, no matter how good or well received, will have room for improvement as time and technology progress. Cummins is now introducing the Isb engine, the latest generation in the mid-range line of engines. New emission standards, the benefits of engine electronics, and the opportunity to improve the product were all driving factors in the Isb design. Let's begin this discussion by seeing just how different the Isb engine is from its predecessor, the highly successful and proven B-Series engine. These changes include a new base engine system with a 24-valve cylinder head, an all-new Bosch VP44 electronic fuel pump, and the associated electronic controls and various product improvements. Engine horsepower has increased, now ranges from 175 horsepower up to 275 horsepower, with a maximum peak torque of up to 660 foot-pounds. However, the 275 rating is restricted to a few specific applications. The engine also has a governed speed RPM on light-duty pickup models up to 3,200 RPM. All of these new features, plus the previous success of the engine, have resulted in expanding the market for the Isb to many new areas. Hundreds of new parts and new options are available, as well as many exciting new electronic features. These options, the features of the engine, and the outstanding reputation have helped in expanding the market for this world-class engine. The Isb engine has retained and expanded upon the features that have made the B-Series engine a leader in the medium-duty diesel engine class. The compact design, fuel efficiency, and proven reliability and durability make the Isb engine well suited for pickups, RV applications, medium-duty trucks, buses, industrial and agricultural applications, as well as specialty applications. The six-cylinder engine has a displacement of 5.9 liters. The following segment will briefly describe the components of the Isb engine. Select whether you want to view this section continuously or one scene at a time. Let's begin by taking a look at the major components of the Isb engine. Begin with the engine block. The new engine block has straight thread O-ring fittings, the engine serial number stamped on the block, and new internal drillings. Piston cooling nozzles supply a stream of oil to cool piston during engine operation. The crankshaft uses a signal indicator ring to detect engine speed. Crankshaft is held in place by main caps and 12mm cap screws. The rear oil seal housing provides a mounting location for the rear crankshaft seal. The pistons and ring packs are matched for the desired rated horsepower range. The angle split rod design cap allows for the largest possible connecting rod crankshaft bore. The wall thickness of the camshaft bushing has been increased. The front gear train uses a wider housing to accommodate the air compressor and wider gears used on the Isb engine. Tappets and cam lobes have been widened for increased durability. The redesigned head gasket provides for improved coolant flow. 24-valve cylinder head contains a centrally located injector recess and an integrated fuel return rifle. The 4 valves per cylinder control the airflow in and out of the cylinder. The valve springs have been redesigned to accommodate an exhaust brake. Longer push tubes, crossheads, and rocker levers complete the 4-valve per cylinder design. The injectors in the Isb engine are centrally located. The fuel connector installs between the injector and the high-pressure fuel lines to supply fuel to each injector. The all-new fuel system utilizes a Bosch VP44 fuel pump. The fuel pump drive gear is now keyed to the fuel pump drive shaft. The reusable gasket and one-piece valve cover provide a new look to the engine. The redesigned oil passages and pump provide for improved lubrication oil flow. The redesigned water pump installs into the integral water pump volute in the front of the cylinder block. The thermostat for the Isb engine has a redesigned vent system. The thermostat mounts vertically in the integral thermostat housing. The redesigned oil cooler installs in the integral housing in the cylinder block. The cooler cover provides a mounting location for the oil filter. Spud size for the oil filter has increased. The oil filter contains an improved oil filtration media. The water inlet connection with a fill line not only supplies coolant from the radiator when needed, but also aids in venting the cooling system during the initial fill. The front cover is made of laminated steel and houses the front crankshaft seal. Oil pan and suction tube supply oil to the oil pump for lubricating oil flow. A 1- or 2-piece exhaust manifold is installed using redesigned mounting hardware. An optional coolant block heater may be installed at the oil cooler housing. The X35 waste-gated turbocharger supplies intake air to the engine. The flywheel housing and flywheel install on the rear of the engine. A grid heater is installed onto the intake manifold cover to assist with cold starts and white smoke. Preheat and post cycles are ECM controlled. The Isb engine uses 2 different fuel filter designs. The Isb engine utilizes an electronic control system that consists of an electronic control module, sensors, and a wiring harness. The electric lift pump provides positive fuel flow to the fuel pump. The new design air compressor installs onto the back side of the gear housing. Various optional alternator and belt tension mountings are available. This completes our overview of the new Cummins Isb engine. The purpose of this course is to provide the student with information covering the Cummins Isb engine. After completing this course, the student will be able to describe the new features, components, and parts, trace the system flows, and perform unique troubleshooting and maintenance procedures utilizing system operation concepts. This also evaluates and monitors the student's progress in obtaining a level of knowledge needed for service procedures on the Isb engine. Upon successful completion of this entire course, the student is prepared to enter the hands-on qualification phase of Isb training.